Alright, so this time we're doing problem 37. And it says, suppose the sled in problem 36 is initially at rest when x is equal to 0. Using the work energy theorem, find the speed of the sled when the x position is equal to 8 meters, and when x is equal to 12 meters, ignore friction between the sled and the surface of the pond. And so from the problem move forward, we need to know about that. So it says, a child applies a force parallel to the x-axis to a 10 kilogram sled on a frozen surface of a small pond. As the child controls the speed of the sled, the x component of the force she applies varies with the x coordinate of the sled as shown in figure E6.36. Calculate the work done by the force when the sled moves. So, this graph is the figure that is my representation of the figure from the problem. From the other problem, we learned that the sled has a mass of 10 kilograms, and we know from the problem we're trying to solve that it has an initial x position of 0 and an initial velocity of 0. Then wants us to use the work energy theorem to find the velocity of the sled when it's at 8 meters. So our graph here is force over position. So we know the area under the curve is going to be the work. So we also need the work energy theorem, and that is that W is going to be equal to 1/2 the mass times the final velocity squared minus 1/2 the mass times the initial velocity squared. Luckily for us, the initial velocity is going to be 0, so that whole term is gone. But we don't know the final velocity, and we don't know the work, but we have the two distances when this is done. And the graph tells us the force to that distance. So we can find the work using geometry, finding the area of the triangle from this graph. So work is going to be equal to 1/2 the base times the height. So for the first part, when the sled's gone 8 meters, we're going to use that 1/2 the base, 8 meters, times the height, 10 newtons, is going to be equal to 1/2 10 kilograms times the velocity squared. We then isolate for velocity, so that would be velocity is going to be equal to the square root of those would cancel out, so you would have the base times the height divided by the mass. And so when you do the math, so you plug those values in, 8, 10 divided by 10, you get the square root of 8, and that is going to be equal to 2.83 meters per second, and that's your velocity when the sled has gone 8 meters. Part B wants to know the velocity when the sled has gone 12 meters. And so we're just going to split this graph into two right triangles where the dotted line is, because that makes it easier to find the area. So for B, our work is going to be equal to 1/2 base times the height plus 1/2 second base times the height of the second triangle. So that's going to be equal to 1/2 8 times 10 plus 1/2 12 minus 8 times 10. And so we get that the work is going to be equal to 60 joules. We can then use this same formula to find the velocity. So work is going to be equal to 1/2 mass times the final velocity squared. So velocity is going to be equal to the square root of 2 times the work over divided by the mass. When you put your variables in, that becomes 2 times 60 divided by 10, all of that under the square root. And that gives you a velocity final velocity of 3.46 meters per second when the sled has gone 12 meters.